Okay guys, welcome back to my channel. Now today's video is going to be about physics. Now JAMB exam starts tomorrow for those of you that are writing the exam from tomorrow and above. And now you must watch this video if you know you'll be taking the subject physics in your JAMB examination. Okay, now these questions are the questions you should expect and see in your exam from tomorrow going on. So let's not waste time. Let's start with number one. As shown on the screen, it says, which of these colors is in the visible spectrum has the longest wavelength? I'll say it again. Which of these colors in the visible spectrum has the longest wavelength? Okay, now options given: option A red, B blue, C yellow, and D violet. Which of these colors, okay, in the visible spectrum has the longest wavelength? Okay, now red, blue, yellow, and what now? Violet. Now quickly remember, for our visible spectrum we have the colors of light as ROY, G, B, I, V. Okay, where R stands for red, O is for orange, Y is for yellow, G is for green, B is for blue, I indigo, and V violet. Now remember, okay, the speed of these colors reduce as it is going this way. Okay, so the speed or the velocity reduces as it is going this way, meaning red has the highest speed. Now because red has the highest speed, the question we ask, which has the longest wavelength? Okay, remember, velocity is equal to frequency times wavelength. Okay, so velocity and wavelength are directly proportional. So if you have a higher velocity, you're going to have a higher wavelength. Okay, so therefore the color of light with the highest speed should also have the what now? The highest wavelength. And what's the answer? A. Red is the answer to that question. Question number two. Question number two, as shown on the screen, says, okay, the power of a lens in diopters is, the power of a lens in diopters is, now quickly remember, for lens, the power of a lens is basically 1 over the focal length. Okay, so P is equal to 1 over F. Okay, so the answer to the question is option B, 1 over F. Now number three, this is question one. Okay, question two. Now question number three that you must expect says, as shown on the screen, a man moves 6 meters east and then 10 meters north, 30 degrees of east. How far is he from his starting point? How far is he from his starting point? Now quickly, the question under vector. Now how do we solve questions from vectors? Very simple. You're going to start your diagram from the starting point. Now the question says a man moves 6 meters east. So let's, for example, this is the man's starting point. You draw your cardinal point. Remember, the top is north, the right is east, the bottom is south, and the left is west. Remember, in case you forget, we use the acronym called NEWS. NEWS, okay? NEWS, NEWS. Now the man moves 6 meters. It means from here he moves in this direction 6 meters. Okay, so the man is now somewhere around here, and then it was said, and then 10 meters north, 30 degrees east. So from this point we draw a new cardinal point. This is north again, and this is east, so it moves this way in this point, and this is what now? 30 degrees. Okay, so now the man is somewhere around here. Okay, now 10 meters to here is 10 meters. Okay, so let's put these meters underneath so we don't have an issue there. Now quickly, we're now asked to find the distance from, rather how far is he from the starting point. So this is the starting point, this is the final point. So you're going to connect the dots together. Okay, so this is what we're looking for. Okay, so quickly we have that diagram on the board. We look for the value. Now, if they've asked you to find just distance in this question, the distance traveled, okay, the normal distance, okay, will just be the addition of both values. That's 6 plus 10, which should give you 16 meters. But now, this question is talking about the vector, that's the displacement. Okay, so the displacement is a vector quantity. It's a what? It's a vector what now? Quantity. So we need to apply the rules or the vectorial algebra in solving the question. Now quickly, we know that since here is 30, the angle you should have here normally should be 90 degrees. So everybody here should be 120 degrees. You're going to apply the cosine rule to find the displacement. What does cosine rule say? We're going to say the square root, okay, of 6 squared plus 10 squared minus 2 6 times 10, okay, cos 120. This is the cosine rule. So this should give you square root, okay? 6 squared is 36, 10 squared is 100, 6 times 10, 60 times 2, 120. What's cos 120? Cos 120 is negative cos 60. So you have minus 0.5 over here. Okay, so equals to the square root again. We have 136, okay? Minus equals a positive sign, okay? Then half becomes 60, okay? So you have 136 plus 60, that gives you 196. Okay, now quickly, what is the square root of 196? The answer should be 14. So the answer to the question for displacement is 14 meters, while the distance is 16 meters. Okay, that's all for number 2. Question number, so that's number 3. Question number 4. Question number 4 says, the density of water. Okay, let's come over here. Okay, question number 4. It says the density of water is 1 grams per cm cube, while that of ice is 0.9 grams per cm cube. Calculate the change in volume when 90 grams of ice is completely melted. Now, this is from density and what now? Options. Now, remember, recall that density is equal to mass divided by volume. Okay, mass divided by volume. So we have for water and for ice. Quickly, let's talk about how to find the volumes respectively. So the density of water was 1, density of ice is 0.9. Okay, now remember, since we're talking about water, the mass of water remains the same. So let's do something quickly. The density of water will be the mass of water over the volume of water. Okay, now quickly, if we're looking for the volume of water, this should be the mass of water over the density of water. Okay, mass of water and then now the mass was given as 90 degrees. The mass was given as 90 degrees. So quickly, we're going to say the volume of water becomes, okay, 90 divided by the density of water given as 1. So this should be 90 cm cube for water. Now for ice, we're going to say the volume for ice becomes the mass again of water or ice, anyone, divided by the density of ice. Now the mass remains 90 from the question. So we have 90 over the density of ice in the question was 0.9. Okay, so this should give you, I think, about 100. So 100 cm cube. Now check the volume of water was 90, while for ice was 100. Now what's the difference in volume? The change in volume becomes, okay, within 90 minus the 100. That gives you a negative 10. Now negative 10 means it is actually 10 cm cube, okay, but it is a decrease. The answer is 10 cm cube, but what now? A decrease. Okay, so that option D is the answer, 10 cm. But in case you went further, it is not an increase. Okay, it is what now? A decrease. Okay, that's the answer for that question. Okay, question number 5. According to the kinetic theory of gases, the pressure exerted by a gas on the walls equals, that's the question, and the options are shown on the screen. Now remember, pressure is basically equals to force over area. Okay, so our answer should contain something about force divided by area or per unit area. But now in the options, we have momentum in the options. So quickly, recall from Newton's second law of motion that force is equal to the rate of change of momentum. Okay, so force is basically the rate of change of momentum. So we can say pressure is the rate of change of momentum divided by area. That can be seen as the rate of change of momentum per unit area. So the correct option to that should be option D. Okay, option D. Question next, number 6. Which of the following is not true about a wave in a plucked string? Now, quickly, waves in plucked string, we all know that they are mechanical waves, okay, because they require a material medium for their propagation, and waves in plucked string always move perpendicularly, okay, to their point of propagation. Whenever as a wave you move perpendicularly to your propagation, rather, we call those kind of waves, we call them transverse waves. Okay, transverse wave, because they are perpendicular. However, when you move parallel, we call you longitudinal wave. So the correct option to that question is option D. That is not true. They are transverse waves. So option D is correct. Number 7. The EMF of a cell is the potential difference across its terminals when it is in dash. Okay. Now quickly, it's not waste of time. EMF basically is the voltage in an open circuit. So the key word here is open circuit, and the correct option to that is option C. Okay, quickly moving on, number 9. The thermometric property of mercury is based on the change in. Now, when you hear the word thermometric, we are talking about liquids that respond or react equally or evenly to change in temperature, meaning when you increase the temperature of this liquid, they tend to either expand or reduce or contract, okay, at a certain equal or steady rate. So the answer to this question should be option B. Okay, so change in volume with temperature. So when your volume is changing, you're either increasing or you're contracting. Okay, so that's option B. So the next question, number 9. Some of the features of the human eye that greatly helps to refract light entering the eyes are, okay, so now this time the answers are option A, the cornea and the lens. Okay, the cornea and the lens help to reflect the light entering your eyes, okay, just like that of the camera. Okay, so that's option A should be the correct answer for that question. Okay, question number 10. When both the object and its image move together in the same direction relative to the observer, then there is, now see what's happening here, both the image, okay, and the object, they are moving at the same time together. Okay, so when an observer is looking at these two pictures or images rather, you're going to see them in the same line, so because they're always in the same line, there's no error due to parallax. Okay, so whether you look from this angle or from this angle, you're going to see them at the same line. So the answer should be option A, no parallax error. Okay, that's for number 10. Then quickly, question number 11. A force 18 Newton pulls a mass. Let's write the parameters out quickly. The force is 18 Newton, okay, pulls a mass. The mass was given as 40 kilograms, okay, on a horizontal floor at 0.3 meters per second squared acceleration. Find the coefficient of friction. So we have these properties from this question, the parameters. Now we are asked to find mu. Recall, for you to be able to move an object on a rough surface, it means that your applied force must be greater than the frictional force. Okay, So the applied force must be greater than the frictional force. Whenever that occurs, we're going to say the applied force minus the frictional force must be equal to the moving force. Now, for horizontal cases like this, the frictional force is always equal to mu mg, where mg is the normal reaction. So we have Fr equals mu mg. Now, to put the values into the question, F was given as 18, so we have 18 minus Fr is mu, unknown, the mass is 40, and then G is 10, and then M is 40 again, and then the A was 0.3, okay, 0.3. Now quickly, we're going to simplify this question like it's in JAMB, okay, without a calculator. Now quickly, 0 point can take out 0, okay, 0 point can take out, but this is like 3 over 10, 3 over 10. So 10 takes out 0 here. We have 4 times 3 here. So we have 18 minus 4 times 3 gives you 12 equals to, these guys come over this direction. You're going to have 400 times mu. 18 minus 12 gives you 6. So equals to 400 mu. Okay. So dividing both sides by 400, our answer is going to be mu equals 0. Okay, I think, yeah, 0.015. Okay, 0.015. So that's the answer to that question. Question number next says a 500 watt electric oven. So the power was given as 500 watts. Okay, is plugged into a 220 volt. So the voltage was given as 220 volts. Will consume an electric current of, okay, question number 12, a 500 watt electric oven. So the power was given, power was 500 watts, okay, it's plugged into a 220 volt source. So the voltage is 220 volts, okay, and then it will consume an electric current of that. So we're looking for the current. So recall the electrical power equals to electrical current times voltage. P equals IV. So we're asked to find I. So quickly, I should just be P divided by V. So P is 500, okay, over 220. So 0 takes out 0. So we have 50 over 22, and the closest option there, 2.27, okay, amperes. That should be the answer to that question. Okay, the next question we have over here, question number 13. I'm going to solve it over here. Okay, question number 13 says a hydraulic press consists of two cylinders of cross-sectional radius R1 and R2. If a force of 200 newtons is applied to a smaller piece in R1, causes a force of 3,200 newtons to be transmitted onto the larger piece in R2. The ratio of R1 to R2 is dash. Now quickly, for your hydraulic press, it works based on Pascal's principle of transmission of pressure, which says that when you apply pressure to a part of a fluid, okay, the pressure at point 1 must be equal to the pressure at point 2. Recall that pressure equals force over area. So we can say the force at 1 over the area of 1 must be equal to what? The force at 2 over the area of 2. Now we can also derive further, since they are circular shape for pistons, circular, so the area should be area of a circle. So for first one, we have F1 pi R1 squared, and then we have F2 and pi R2 squared. Okay, so now quickly, pi can take out pi, so you can just say F1 over R1 squared equals F2 over R2 squared. Now quickly, F1 was given as 200 newtons, so we have 200 divided by R1 squared equals to the F2 was given as 3,200 newton. So we're going to have 3,200 newton over R2 squared. Quickly, before we move on, we can easily take out zeros, okay, together, and then 2 here, 1, 2 here, 16. Now we need R1 ratio R2. So R1 should be on top, and then R2 should come under. So R1 squared over R2 squared should then be the reverse of this fraction. So we're going to have 1 over 16. So take the square root of both sides to take out the squares. Okay, so square root cancels the squares. The square root of 1 is 1, and then 16 gives you 4. So the answer should be 1 1:4. 1:4. Okay, next question. The gravitational pull between two bodies is 20 Newton. Find the gravitational pull when their distance of separation is double. Now, this is from Newton's law of gravitation. Okay, now quickly recall, Newton told us that the force, okay, is inversely proportional to the square of the distance apart. So if you bring out your constant term, you're going to have F1 R1 squared equals to F2 and R2 squared. Okay, remember this formula. It's very, very important to remember that. Okay, now the first one was given as 20 Newton, so we have 20 Newton, right? Yeah, and then R1 is also R1 squared, and then we're looking for the first two, but the R2 is now twice the initial one, so R2 becomes 2 R1. Don't forget the square. Okay, so 20 R1 squared equals to F2 times 2 squared gives you 4, and R1 squared. R1 squared takes R1 squared. 4 here, 1, 4 into 20 is 5. So the next force should be 5 Newton. So if you observe, the force reduces when you double the distance because it says they are inversely proportional. So the more the distance, the less the force. Okay. So the next question number next says the volume. Okay. The volume of 1 cm cube metal ball increases by 0.0018 cm cube. That's the change in volume when heated through a temperature of theta. If the linear expansivity of the ball is 2 times 10 raised to the power minus 5 per Kelvin, find theta. Now this is from heat expansivity, okay, cubic to be precise. So we call for cubic expansivity we have gamma to be change in volume over original volume times the change in temperature. But don't forget that gamma is also equal to 3 times alpha, where alpha is the linear expansivity, which was given in the question. So let's solve the question quickly. You're going to have 3 times 2 times 10 raised to the minus 5, okay, equals the change in volume was 0.0018 divided by the original volume was just 1, and then we're looking for the change in temperature. We're going to solve this like a JAMB question, okay? So let's take the values of zeros. 1, 2, 3, 4. So we can say this also 3 times 2 is 6, remember? We're going to have 6 times 10 raised to the minus 5 equals, we're going to have 18 times 10 raised to the minus 4 all over theta over 1. 6 here, 1. 6 here, how many? 3, okay? And then if you cross multiply, or you can just quickly say 10 raised to the minus 5 actually means 10 raised to the minus 4 times 10 raised to the minus 1, right? So this should take out this, and then you have just 3 here, and this guy is going down. Okay, so theta comes here. Theta should be equal to, we have a 3 here. Now remember, 10 raised to the minus 1 means 1 over 10. Okay, so 10 times 3 should give you what? 30. So the answer should be 30, option C. Okay, the next question quickly. It says, for a gas, which pair of variables is inversely proportional to the other? So we have inverse here, inverse for a gas. Now recall for gas laws, okay? Boyle's law says the pressure and the volume are inversely related. Okay, so P and V, option B should be the answer to that question. Okay, P and V, that's Boyle's law. Number 20 says a boy uses a single pulley system, that's one pulley, to lift a mass of 20 kg, moving with a velocity of 5 meters per second. What is the power developed by the boy? Okay, the power. Now quickly recall, power is the rate at which work is done. So power is work done over time. Now work is force times distance over time. Okay, distance over time gives you V. So power can be force times velocity. Okay, so quickly, to get the force here, it's going to be the weight. So the force in this case is going to be the weight of the object. Okay, so this should be, the mass was 20 times G is 10. That should give you 200 Newton. So the power should become the force as 200 times the velocity as 5. and this should give you 1000 watts. Okay, so 1000 watts should be the answer to that question. The next question says, without considering the containing vessel, what mass of boiled water can raise the temperature of 8 kg of water from 25 degrees Celsius to 16 degrees Celsius? Now, this one heat. Remember, heat given off by hot body equals to heat received by cold body. So for the hot water, you want to say the mass of the hot water, okay, C of hot, and temperature change for hot equals to mass of cold, C of cold, and the temperature change for cold. And not to waste our time, the C for hot water and the C for cold water are the same. Why? In pidgin, I can say water. Now water, so therefore CH can cancel CC. So quickly, the mass of hot water is what we're looking for, okay? So MH. Now, the temperature change will be the higher minus the lower. For the hot water, the higher is the higher temperature, okay? And which is the boiled. For you to be boiled as water, you must be at 100 degrees Celsius. Minus the lower one is the final one at 60. Okay, so we have this here over equals to the mass of cold remains as 8, and then the change for this guy is 60 minus 25. Okay, so we have 40 nh equals, this should give you 35. 35 times 8, what should that be? Let's see quickly. Okay, let's just do that. Okay, 35 times 8, we have it over here. Right, now quickly we can just quickly divide from here to get what we're going to get. Okay, so quickly 4 can go here 10, and 4 goes into here 2. 2 here 1, 2 here we have 5. Okay, and then 5 here 1, we have 7. So the mass of hot should be 7 kilograms. Okay, 7 kilograms. Number next, which of the following has the least thermal conductivity? Air, ash, glass, and water. Thermal. Okay, the answer for this should be A. Option A.